about infinite limits. So limits as x was going to positive or negative infinity, and we talked about some where we were getting positive or negative infinity as our answers, and we said these are really vertical and horizontal asymptotes. The limit as x approaches positive or negative infinity is giving you the horizontal asymptote. If you do the limit as x approaches a number and get positive or negative infinity for an answer, that's where your graph has a vertical asymptote. Let's talk about a few more. If I said the limit as x approaches infinity of x cubed, a couple ways we could get it. We could make a table. We could think about the graph. What does x cubed look like? As x goes to infinity, what's your graph going to? Infinity. What about as x goes to negative infinity? Now, are those asymptotes? No. I was approaching infinity and I got infinity for an answer. So these are just graphs that continue to increase or decrease as time goes on. Now, in general, this wasn't hard to figure out, but if I did something like x cubed minus x squared, that would be harder. So if I gave you this one, if I just plugged in infinity, infinity squared minus infinity, do we know what that goes to? No. Do I know what the graph of x squared minus x looks like off the top of my head? No, not without doing a lot of work to get there. So, in general, limit laws can't be applied to our infinite limits. So, I can't just say I'm going to do the limit of each piece and subtract them. However, algebra still works. X squared minus x. If I told you to try to simplify that algebraically, I can't actually subtract them. Is there anything I could do? Let's factor out an x. Okay. If I look at that, if I plugged in, that's infinity. What's infinity minus 1? If you take a huge number and I subtract 1, what am I left with? Still a huge number, right? So I really have a big number times a big number, so what do you think I'm going to get? A big number. The reason is the product of large numbers is large. Okay, that would work if I'm adding. If I add two really big numbers, I'm going to get a really big number. If I multiply, if you multiply two really big numbers, you get a really big number. Would that work with subtracting? If I subtract two really big numbers? No. What about dividing? If I divide two really big numbers? No. So this will only help me if I can rewrite it so that it's a product or a sum. Otherwise, I still can't quite figure it out. All right. So what if I wanted to try to figure this one out? Yesterday we did one with our rational functions. Do you guys remember what we tried? It was somewhere in here. Yeah, here. We said we couldn't just plug in the infinities because we didn't know what they would go to. But we knew that if we had a number divided by infinity, it would turn into 0. So we divided everything by the highest power of x, and then we were able to simplify. So when I have those fractions, that's a solid strategy. If I try multiplying, what's my highest power of x? on top, so if I do 1 over x squared. Okay, so then I get 1 minus x over x squared would be 1 over x. Over x squared minus x over x squared is 1 over x. Is this helpful? Okay, if I put in infinity, I get 1 minus 1 over infinity turns into 3 over infinity squared, 1 over infinity. Oh, what's wrong? It's undefined. We can't have 0 on the denominator. Okay, so solid strategy, but we had an issue because I'm getting 0 on the denominator. What else could I try? If I go back to this multiplying by the highest power of x, my issue was that I had more x's on the top than the bottom, right? What if I divided by 1 over x on top and bottom instead of 1 over x squared? So x squared over x would be x, minus x over x will go to 1, 3 over x minus 1. Now if I put in infinity, on the top we get infinity minus 1, 3 over infinity is 0 minus 1. So we have a really big number divided by negative 1. So what do we get?
Negative.
So these problems, you're not always going to get it on the first try. Okay, we had to go back and modify our approach, and that's because we had a higher power of x on the top than the bottom. Questions there? I think I'm going to skip this example for now, because we're going to do some more graphing stuff later on where we'll have a lot more detail, so we'll just save that for then. Let's look at go ahead and try these questions. It's a good kind of wrap up. If I asked you to find this limit, what strategy do you think you would use? 1 over the highest power of x. Okay, why don't you guys try it? Alright, so you take everything times 1 over x cubed. So we have 1 over x cubed plus 1 over x plus 2. On the bottom we get 1 minus 5 over x minus 3 over x squared minus 5 over x cubed. Anything with x on the bottom, if I'm plugging in infinity, a number divided by infinity goes to 0, so you get 2 over 1 or 2. Is that okay? Alright, I wanted to look at a problem out of the textbook. There's some like this on the homework, so I want to talk about one. Grab a book. So this question is asking me to draw a graph to meet a lot of different requirements. If I am going through this, there's not just one possible answer. And you're probably going to have to adjust your graph as you go. Alright, so if I look at problem 9, the very first thing it tells me is f of 0 equals 3. What would that be? Adopt. When x is 0, y is 3. That's just adopt. Okay, we know it's a function, so remember, any other points when x is 0 would have to be open circles. Right? If I said the next condition tells me the limit as we approach 0 from the left is equal to 4. So as I'm coming in from 0 from the left, it's going to 4. Can I put a closed circle there? No, it would have to come into an open circle. Okay, do I know what it's looking like? Not really, just that's going to there. So draw something, but know that we might have to come back and change this in a little bit. So as I'm coming in, it's going to 4. Limit as we approach 0 from the right is equal to 2. So again, it would have to be an open circle. All I know is as I'm coming in, that's going to 2. Might have to change my graph as we go. The limit as we approach negative infinity is equal to negative infinity. So as I go forever in the negative direction, my graph has to be going down. So I have to modify my graph. And I know that this has to be decreasing. So that's going to negative infinity. The limit as we approach 4 from the left equals negative infinity. So as I'm coming into 4, that has to be going to negative infinity. If I look, the next condition tells me the limit as we approach 4 from the right is equal to positive infinity. What's happening at 4? Vertical asymptote. Alright, I'm going to have to change this. Now I have a vertical asymptote here. So all I know is this has to be going here, and as I'm approaching this 4, it has to be going down because it's going to negative infinity. So something like that. This one I know it's going up. That's all I really know. The last condition tells me the limit as my graph goes to positive infinity equals 3. So as I go off forever, it's getting closer to 3. So what's happening at 3? Alright, so if I ask you to draw a graph meeting all these requirements, you are probably not going to be able to read every one of those requirements and just magically know what your graph is going to look like. There's a lot of information. But if you take it step by step like we did and tweak your graph as you go, then you'll be okay. Any questions there? Okay, so we're doing a couple things. I did give you guys problems yesterday, but we're not working on these quite yet. I want to do a handout that I posted on Classroom. Right, the top is 1, no matter what. The bottom, if I put in 0, or put in 6, it's going to 0, but I'm approaching 6 from the right. That tells me I'm putting in something bigger than 6. So when you approach 6, it's getting closer to 0, but it's a positive number. Okay, so it's like 6.1 minus 6, 6.01 minus 6. What happens if I take 1 and I divide it by a smaller and smaller number? It's getting bigger and bigger. So think like 6 divided by 0.1 is 10. 6 divided by 0.01 is 100. 6 divided by 0.001 is 1,000. So this is getting bigger and bigger. Yesterday I used that pizza analogy. You know, if I start with a whole pizza and I invite the whole school and you're barely getting anything. But as I start kicking people out of our room, the number of people going in our class is getting closer to 0. What's happening to the amount of pizza you get to eat? It's getting bigger and bigger. So that would go to infinity. So number 2 is about the same, but you're approaching 6 from the left. 2 by the same reasoning. You get 1 over x minus 6, so the top is 1. The bottom is going to 0, but since you're approaching from the left, you're putting in something smaller than 6, so you get a negative. So 1 divided by a smaller and smaller negative number goes to -10. So then, number 3, the overall limit. What you know is from the right it's going to infinity, from the left it's going to negative infinity. So what's my overall limit? It only exists if the left and right are the same. Okay, did we get those? Number 4, as I approach 0 from the right, what kind of number am I plugging in then? A positive. Okay, if it's positive, does the absolute value change anything? So this is just like x over x, which is 1. So the limit as you approach 0 of 1 is number 5. If I am approaching 0 from the left, that means I'm putting in a negative number. What does the absolute value do to it? It makes it positive. So it's the opposite of what you put in. So that means x divided by negative x would be -1. So now it is -1. Do we do okay reasoning through those? Have you guys talked about the last few, or do you need a minute? Okay. So is there anything that would factor and reduce here? No. Okay. Let's see then. Can we just reason through it? If I plug in 7 from the right, so the top is just going to 7. The bottom, 7 squared minus 49, is going to 0. But can we tell, is this from the right or the left? It should be from the right. You're plugging in something bigger than 7. So when you square it, it's bigger than 49. Okay. So if I have 7 pizzas in my classroom and the whole school is in here, you're getting very little pizza. What happens as I kick people out of the room? You're getting more and more pizza. So as our number of people goes to 0, the amount of pizza you get is getting bigger and bigger. So this will go to infinity. We're getting a bigger and bigger number. Alright, on this one, top is going to 7, the bottom is going to 0. Now I didn't tell you if you're approaching 7 from the left or the right. So I don't know if x minus 7 is positive or negative. But I'm squaring it. So what will it become? So 7 divided by a smaller and smaller positive number? Number 8. Nothing factors. If I plug in a 3, the top is 5, the bottom is 0. Did I tell you which way we are approaching 3 from? No. So it could be 5 divided by a smaller and smaller negative number, or it could be 5 divided by a smaller and smaller positive number. Will those things match? No. What's happening is 3 is a vertical asymptote. If you're putting in something smaller than 3, you're going to get negatives. If you put in something bigger than 3, you're going to get positives. So overall, they don't match. So this one does not exist. So number 9, I'm still just approaching 3 from one side. So I don't know if I'm plugging in things bigger or smaller than 3. The top is going to 5. The bottom is going to 0. But I'm taking x minus 3, which could either be a positive or a negative number, and I square it, so I know it is positive. What happens if you take 5 and divided by a smaller and smaller positive number. Making it bigger and bigger. That one's approaching infinity. I want you guys to look at number 10. Try to draw a graph if you need to, and see if you can answer those questions. First piece, if you plug in a 3, you get 4. Add equal to, so closed circle. If you put in a 2, you get negative 1.
Yeah, but this.
You put in 1,
This
you
is
get
at 0, and it only exists when x is greater or not you, like it'll be less than.
and you can do more points if you need to, but hopefully you recognize that this is a parabola. It's extending for less than 3, so it keeps going that direction. On this piece, you start with 3, which gives you 5, but that would be an open circle because it wasn't equal to. Put in 4, you get 6, and so forth. So it looks like that. So what happens is you approach 3 from the left. You can use the graph, or you may not have even needed to draw the graph. So I put it up here as a visual. If you're approaching 3 from the left, which piece are you on? You're less than 3, you're on the top one. So you get 9 minus 5, or 4. Is that what happened on my graph as I'm coming in from the left? Did it go to 4? So if I'm coming in from the right, if you didn't draw the graph, you could have said, okay, I'm plugging in things bigger than 3, so that means I'm on the second piece. So I get 3 plus 2, which is 5. Is that what happened on my graph? Overall limit. What happens? Does not exist. What kind of discontinuity is that? Jump. Good. All right. This is where I'm stopping today. Technically, we are done with the notes. We will probably do some problems together tomorrow as well to continue practicing this. And you will have class time to work on homework tomorrow. So this will be due on Thursday. You'll have a large chunk of class to work on it, but we will probably do some class problems. And you have a few minutes